As the continuation of our discussion on the use of array variables in Fortran, today we shall use the array variables to perform the matrix operations. If we have two matrices A and B, then we define the matrix C is equal to A plus B, and we define D as A minus B. In terms of components, Cij is equal to Aij plus Bij, and similarly Dij is equal to Aij minus Bij. The matrix operation is this addition and subtraction are possible only when the matrices A and B are of same order. That is, the number of rows of A is equal to number of rows of B, and number of columns of A is equal to number of columns of B. Otherwise, the matrix addition and subtraction is not possible. So the program that I am going to do is that I shall assign two matrices A and B as two-dimensional array, and it will have number of rows NRA and NCA, number of rows of matrix A and number of columns of matrix A. Similarly, NRB and NCB will be the number of rows and columns of matrix B. Then we shall check for the equality of the dimension, that is, this must be equal to this and together with this equal to this. If this is possible, then the matrix addition and subtraction is possible, and we shall then read the matrices A and B and then perform this process. This is the main outline. So the program reads like this. Dimension blank. For A matrix we write it is 10, 10. For B matrix, so this can handle up to, and addition matrix C is equal to 10, 10, and the subtraction matrix 10, 10. If you want to deal with matrices having still higher dimension, then these numbers are to be increased appropriately. Then or this, if the number of rows are not equal, or this, then write matrix addition and subtraction are not possible. Stop. So this part of the program first checks whether the two matrices has the A and B have the same dimension or not. If not, it just gives you the message that the matrix addition and subtraction are not possible, and the program stops over there. And if this condition is satisfied, that is NRA equal to NRB together with NCA is equal to NCB, program comes to this line. In that case, you see that we need not to deal with separate things. Rather, we define number of rows in R is equal to NRA and number of columns is equal to NCA, which is also equal to the NBs of. So we read first matrix A and then matrix B. And one thing, in general, whenever we talk about a matrix, we write it as A11, 1, 2, 1, 3 up to A1n, and then A21, A22, etc. This is the general way in which we use to represent a matrix. I first want to make an arrangement so that the matrix A can be read in this fashion. If you want to write it in something else, then some mistakes may be done. So first thing is that I am keeping one line blank here. I will write it some do blank 10 blank NR, then we die. Now what it does, then I write exactly same thing, and then within 2 to 5 column tens continue. What the program does, it takes say NR is equal to say for example NR is equal to 2 and NC is equal to 3. So it first assumes the value of NR is equal to 1. So it writes 1 over here, but IC is specified through an implicit do loop. So what it does, first this does 1 1, then 1 2, then 1 3. So this is the implicit do loop. It acts horizontally. So taking the first value of IR, which is supplied by an explicit do loop, which is the row, and then the column index is varied by the implicit do loop. Then it reads the first row, writes the first row, then it comes to the 10 statement and goes there and picks up the second value of row where it is 2. So it does A21, A22, A23. So it reads the matrix in this conventional fashion. Here we write matrix A. So it writes a matrix A. Now a similar loop is a similar set of statements are used to write the matrix B. Same thing is to be written there. Then sorry, IR is equal to 1 comma NR. Same thing. So by this part we check whether the matrix addition and subtraction are possible or not. If it is possible, then we define the common row in row number and common column number, and in this part we have inputted the matrix A in the conventional way, and this is same for matrix B. So the program now has read the matrix A and B. Then we are to perform the addition part. So after this we come to another do loop. Do blank 30 blank IR is equal to 1 comma NR. Do blank 40 blank IC is equal to 1 comma NC. Then we define CIR IC is equal to A IR IC plus BIR IC. Similarly, DIR IC then we end the loops. So first the inner loop 40, then we have to write, we can write the matrix C within this loop. Then we write sorry. And to make people know that it is the C matrix we write, we cannot write, if we want to write D in this just after this line, then it will be a problem. The result will write C11, C12 up to C1n. The second line will be of D, D11, D12, D12 up to D1n, then C21, C22, C2n, then D21, D22, D2n. The result, the output result will be mixed up. We have avoided writing in this fashion, so we have not written D right here. So it will write the C matrix in its conventional fashion. Then we come to write the matrix D. sorry, the statement number has been This is a complete program on the matrix addition and subtraction. Let me first explain the program. By this line, we assign the dimension or the matrices as a two-dimensional array. A and B are input matrices, C and D are output matrices. Then we specify the number of rows of matrix A and columns of A, number of rows of B, columns of C. Then this is a check whether the matrix operation is possible or not. If the matrix addition or subtraction is not possible, then the program gives this message and stops over here. If the matrix addition is possible, the program after this comes to this line, and we no longer want to carry out with NR A or etc. A and B are not required because they has to be same. NRA has to be equal to NRB, so we define NR, number of rows and number of columns. First, we read the matrix A in the conventional form, that is in the matrix form. So in order to do this, we have changed the row index by an explicit do loop. But so row index is an explicit do loop which acts vertically downward, and the column index has been adjusted by this implicit do loop which acts horizontally. The row index acts vertically downward and column index acts horizontally towards the right. So we use an explicit loop to control the row index and implicit loop to control the column index. So it reads the matrix in the conventional form and writes also. This message will be given that it is the matrix A. Then this part, the input of matrix A is completed over here. Then another similar loop has been created to write the matrix, to input the matrix B. Then in this we have implemented the basic operation of matrix, that is Cij is equal to Aij plus Bij, and it has to be implemented for all Injs. So these all Injs are done through two loops, and we have defined Cij is equal to Aij plus Bij and Dij with this. So the inner loop must be completed first. So 40 is completed there. Then we use this row loop to write the addition matrix. That's why this message was written over there. Here this one ends, and then we use another new loop to write the subtraction matrix, and it ends over here. The program ends over here. So this is a program which calculates the sum and difference of two matrices. Now we shall go to the another program, that is the matrix multiplication program. If we have two matrices of same dimension, as we have done NRA, NRB, NCA and NCB, then we define a matrix C is equal to AB, product AB, matrix product. It is defined. So we have a matrix A whose row number is RA and column number is CA, and we have another matrix B with row number RB and column number CB. If we want to define matrix C is equal to AB, it is possible only when CA is equal to RB, they are equal, and this matrix will have a dimension, it is RACB. So this much is this. And if we write C matrix in the component from Cij is equal to sum over k is equal to 1 to common index. Common index means Ca or Rb. Aik Bkj. Let me take an example. First, we have a matrix A. We have consider a matrix A11, A12, A13, A21, A22, A23. This is matrix A, and then matrix B. B11, B12, B21, B22, B31, B3. So it has number of rows. Number of rows is n. Sorry. Ra is equal to 2 and Ca is equal to 3 for this. Rb is equal to 3, Rb is equal to 3 and Cb is equal to 2. So the matrix, since this is equal to this, the matrix operation is, matrix product is possible, and by this what we do is the row column operation. That is, if we call it C matrix C, then C11, we go through the row 1, and this is A11 is multiplied with B11, then A12 is multiplied with B21 plus A13 is multiplied with B31. So this is the one element. So you know that these are the same, only the middle indices changes. Here it is 1, then it is 2, this is 3. This is what we have written in a compact form over here. So it is basically a sum. So here we shall use sum as sum is equal to sum plus term. So first I write the matrix. So dimension again we are restricting it for a 10 by 10 matrix. Then first we should check whether this matrix multiplication is possible or not. If this equal to this, if NCA equal to NRB, then write multiplication possible. Else write multiplication is not possible and stop, program stops over there. So what we do by this part, we have checked the dimensionality of the two matrices, and if the matrix AB matrix product AB is possible, we write that simply matrix product is possible, and if not, we write the matrix product is not possible, and then the program stops over here. So we will be over this line just after the end if line, only when the matrix multiplication is possible. If the matrix multiplication is not possible, program terminates over here. Then we read the matrix first. IR will be NRA. Sorry, 1 comma NRA. Then write the same thing, and then this loop is then from B matrix make a similar segment for B matrix. Only change will be you are to change this part as B, these are B, this one is B, this is B, and you write and change this number to 200, say 200, then it is also 200. So make a copy of this block, and the changes has been indicated either by underlines or two marked ones. So by this way we have read the two matrices A and B. They may be are of different dimensions. Then we are to implement the matrix product. So we do blank 300 blank IR is equal to 1 comma NRA blank do blank 400 blank IC is equal to 1 comma NCB. This part has been already explained in the theory. Then we are to perform this product Cij is equal to Cij plus Aik Bkj. This is basically the term that has been written within using this summation symbol, that is Cij is equal to summation over k Aik Bkj. I have explained the operation. When we write it in the language of computer program, this is Cij is equal to Cij plus Aik plus Bkj. So this is sum is equal to sum plus term. So we need to initialize Cij to 0 for each value of ij. So we initialize this as the matrix is a real matrix, so we have initialized it over here. Then we need to write another loop for k. Do blank 500 blank ik is equal to 1 comma either it is in NCA or NRB. Then we write CIRIC is equal to CIRIC plus AIRIK star BIKIC. Let me check whether the right hand part is visible or not. Yes, it's visible. So thereby we do the perform the sum. This is IRIK and this part is IK comma IC. So this loop has to be completed. So 500 loop is completed. Then we end this loop, 400 loop. Then only this loop is left, and we may write IC is equal to 1 to NCV, and then 300 loop is completed. And finally the stop end. So this is a program which reads two matrices A and B. They may be of different dimensions, that is two matrices may be rectangular matrices. Then firstly it checks whether the matrix multiplication AB is possible or not. If possible, then it first reads the matrix A and then matrix B. Then to calculate the product matrix, elements of the product matrix, first two loops, explicit loops, has been created to for the row and the column indices. Then we have initialized the C matrix, C elements of C, and then we have performed the loop for the row and column operation over the common indices, and then finally we have completed this loop, then this inner loop, and finally we have used this loop to write the matrix and then stops them. So this completes the program for the matrix multiplication. So by this we end our discussion on the operation of matrices. Two homeworks, one homework I want to give you: read the matrix A, this is the input matrix, and then go for A transpose for a rectangular matrix where it is a rectangular matrix. This is homework. Okay, this much for today.